Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories.
The tiny chip that quietly built the modern world. You ever hold your phone and just take it for granted? Thin screen, crazy power, fits in your pocket like it's nothing. But rewind a few decades, and that kind of device would have sounded like science fiction. There was one man behind that shift. Jack Kilby. Not a celebrity. Not a household name. Just an engineer working quietly in the background, who ended up changing everything. Now here's the thing, his path wasn't some smooth genius story. Far from it. Most of his early work looked like failure after failure, long nights in the lab. Broken prototypes. Ideas people literally called unrealistic. Some even thought he was wasting his time. But Kilby had that stubborn kind of mindset: if it doesn't exist yet, maybe I just have to build it. Born in 1923 in Kansas, he grew up in a pretty ordinary family. His father worked with machinery, and that hands-on environment stuck with him. He wasn't the kid everyone called a prodigy, but he was curious, always taking things apart. Always asking what if this could be smaller. That question became his obsession. Fast forward to 1958. He joins Texas Instruments. The electronics world at the time had a big problem: devices were huge, complicated, and inefficient. Everyone was trying to shrink them, but nobody had cracked the code. Kilby had a different angle. Instead of building separate components and connecting them, he asked, what if everything could live on one single piece of material? Simple idea. Almost too simple. And yet, that's exactly where breakthroughs are born. Simple ideas no one believes in at first. People around him weren't convinced. Some thought it was impractical. Others thought it was impossible. But as the saying goes, Rome wasn't built in a day. Kilby kept going. And eventually, he made it work, the first integrated circuit. That moment quietly rewired the future. Computers shrank, TVs got thinner, phones stopped being fantasy and became reality. And modern electronics as we know them? They all trace back to that one idea of putting everything onto a single chip. Of course, it didn't come easy. There were failed experiments, skepticism from peers, moments where quitting probably looked tempting. But he didn't stop. And decades later, in 2000, he received the Nobel Prize in Physics for his contribution to semiconductor technology. Still, even today, most people don't recognize his name when they pick up a smartphone. But here's the irony: every time you unlock your phone, every time you scroll, every time you stream anything, you're holding a piece of his idea in your hand. One man, one idea, and a quiet revolution that changed how the entire world works. Jack Kilby's story begins on February 8, 1923, in a small town called Boonville, Kansas. Picture it: quiet streets, farmland stretching out in every direction, and small workshops filled with the sound of early industrial machines. Nothing flashy, nothing futuristic, just a very ordinary American town. Kilby was born into a pretty grounded family. His father worked as a mechanic, his mother took care of the home. And that workshop atmosphere? It quietly shaped everything that came after. His father was always fixing things: motors, appliances, anything that broke. And little Jack was right there, watching, and eventually helping in his own way. And by helping, I mean taking things apart. A lot. In fact, one of his earliest hobbies was basically turning household devices into puzzles that didn't always go back together. There's this one moment that really sticks. He disassembled the family radio completely, and let's just say, it never worked again. Most parents would have lost their patience. But his father just looked at him and said something along the lines of, "Don't worry. Maybe one day this curiosity will turn you into an engineer." A simple sentence. But sometimes, the smallest encouragement plants the biggest seed. And honestly, that break it to understand it mindset never really left him. As he grew up, Kilby wasn't labeled a genius or anything like that. He was just intensely curious. The kind of kid who couldn't leave a question unanswered. If something didn't make sense, he didn't ignore it, he tore it apart mentally until it did. That curiosity followed him into university. He enrolled at Baker University to study electrical engineering. And like a lot of students, he didn't walk in as a polished expert. He was experimenting, failing, rebuilding over and over again. His early circuits? Let's just say they didn't always survive the demonstration. There was even a moment where he wired something so incorrectly that it short-circuited in front of a professor. The room probably went silent for a second, and then laughter followed. But instead of shutting him down, one professor smiled and said something like, "Kilby, you're going to invent something someday." At the time, it sounded like a joke, but sometimes jokes are just predictions wearing a disguise. As the saying goes, every expert was once a beginner. After Baker University, he continued his studies at the University of Michigan for his master's degree. That's where things started to shift from simple curiosity to deeper thinking. He wasn't just playing with circuits anymore, he was asking bigger questions. Like, how do you actually build complex systems from small electronic parts without everything becoming a mess? And the more he worked, the more he saw a problem nobody seemed to solve properly. Electronic devices were bulky, complicated, expensive, and inefficient. Too many separate components, too many connections, too much space wasted. Kilby started to wonder, what if all of it could be integrated into one single structure? Not separate parts connected together, but one unified system. It was a simple idea, almost too simple to be taken seriously. But history often moves on simple ideas that everyone else overlooks. During his university years, he kept experimenting with small setups, rearranging components, testing concepts that didn't always make sense on paper. Some professors were impressed, others were skeptical. And his friends? They half-joked that he was either going to become a professor or accidentally start a revolution. The truth was, he wasn't rushing anywhere. He was building understanding step by step. And that slow, stubborn process mattered. Because while many people look for instant breakthroughs, Kilby was quietly building something more important: intuition. By the time he entered the professional world in the 1950s, the tech industry was already starting to accelerate. Electronics were evolving fast, but they were still stuck with a major limitation: size and complexity. And Kilby had already been thinking about that problem for years. Every failed experiment, every messy circuit, every classroom mistake, it all added up. He had seen the same issue from multiple angles: things were getting more advanced, but not more efficient. And somewhere in that realization, the foundation of his biggest idea was already forming. Because sometimes innovation doesn't arrive as a lightning bolt. It builds slowly, through frustration, repetition, and a lot of this doesn't work yet. By September 1958, something quietly changed inside a lab at Texas Instruments. No big announcement, no dramatic music, just Jack Kilby, a desk, and a problem that had been bothering the entire electronics industry for years. Back then, electronic devices were still clunky. Huge boards filled with hundreds of separate parts, wires everywhere. If one thing failed, the whole system could collapse like a house of cards. And Kilby started asking a very dangerous question in engineering terms. What if all of this didn't have to be separate? What if the parts could live together on a single piece of material? That idea led him to something nobody had really done before: an integrated circuit. A tiny silicon chip where multiple electronic components weren't just connected, they were built together as one system. And just like that, complexity suddenly became compact. Now, to be clear, this wasn't just a smaller gadget improvement. This was a total redesign of how electronics could exist. Before Kilby, building electronics was like assembling furniture from 1,000 loose screws every time. After him, it was closer to getting a finished product straight out of a box. Less space, less cost, more reliability. Or in plain English, smarter tech that didn't break your wallet. Later, Kilby himself joked about that moment. He basically told his colleagues something like, "I'm not entirely sure what this is yet, but I'm pretty sure it's going to make us money." And it did. But more importantly, it changed everything else too. Because once you shrink complexity, you don't just improve machines, you unlock entirely new ones. Phones, computers, TVs, eventually even spacecraft systems. All of them started benefiting from that same idea: pack more power into less space. As the saying goes, good things come in small packages. In Kilby's case, that wasn't just a saying, it became an engineering principle. And here's where it gets interesting. At the time, nobody fully understood how big this would become. It was just a technical breakthrough inside a lab. One of many, at least on paper. But Kilby had a different kind of intuition. He once joked that maybe future generations would use this technology for incredible inventions, or maybe just to make fancy little gadgets at home. He wasn't wrong either way, because what started as a lab experiment quickly spread across the entire world. Manufacturing scaled up. Companies adopted it. The technology moved from prototype to production and from production into everyday life. And then the real shift began. Computers stopped being room-sized monsters. They became smaller, faster, more accessible. By the 1970s, personal computers started entering homes, and none of that would have been possible without the shift in electronics design. The ripple effects didn't stop there. Communication systems evolved. Satellites became more precise. Space missions relied on compact, reliable electronics. Even early internet infrastructure depended on this same core idea. And slowly, quietly, it started showing up everywhere. Not just in labs or research centers, but in your home. Refrigerators became smart. Washing machines started optimizing cycles. Air conditioners learned to regulate themselves more efficiently. And all of that intelligence? It came from the same hidden foundation: integrated circuits working silently inside. Kilby once reflected on this kind of future with a bit of humor, almost like he was unsure what would come next. Something like, "These tiny chips might change the world, or maybe people will just use them for gadgets we can't even imagine yet." Turns out, it was both. Because integrated circuits didn't just push technology forward, they redefined what technology even means. And the strange part? Most people use them every single day, without ever thinking about the man who made them possible. In the year 2000, Jack Kilby finally stepped into the global spotlight in a way few scientists ever do. He was awarded the Nobel Prize in Physics for his pioneering work on the integrated circuit. And this wasn't just a personal achievement, it was history being acknowledged on the highest stage. Kilby shared the prize with Robert Noyce, another key figure in the development of modern microelectronics. Together, they were described by the Nobel Committee as founders of the information technology revolution. That's not just a fancy title. That's a way of saying, these two helped build the world we now live in. By the time the award was given, Kilby's invention had long left the lab. It wasn't experimental anymore. It was everywhere. Phones, computers, communication systems, household electronics, you name it. And now, the world was officially recognizing what had already quietly changed everyday life. You can imagine the scene: Kilby standing on that stage, Nobel medal in hand, cameras flashing, the eyes of the world on him. But if you're expecting a loud victory moment, that's not really who he was. Kilby didn't treat it like a solo win. In fact, he made something very clear in his acceptance. He credited the broader team behind the work, saying in a light, almost joking tone that the award really belonged to everyone involved in developing the integrated circuit. That humility says a lot. As the saying goes, if you want to go fast, go alone. If you want to go far, go together. And Kilby understood that better than most. Because even though he is one of the central names in this story, he never believed innovation was a one-person job. Breakthroughs like this don't happen in isolation, they happen in ecosystems of engineers, researchers, and constant trial and error. Still, make no mistake, Kilby and Robert Noyce were absolutely pivotal. Their work took the integrated circuit from a lab concept to an industrial standard. And once that happened, everything accelerated. By the 1970s, microelectronics had exploded into mainstream use. Devices shrank, costs dropped, performance skyrocketed. And Kilby, looking back, admitted something quite honest. He never expected it to go this far. He once reflected that when he first imagined the idea, it didn't feel like a world-changing invention. It felt more like an experiment, a technical workaround, a clever idea inside a very specific engineering problem. In other words, he didn't see a revolution. He saw a solution. And that's often how revolutions begin. Because at the time, nobody was saying, this will redefine global communication, or this will reshape civilization. It was just a better way to design circuits. But over time, that better way became the foundation of modern technology. Today, integrated circuits are everywhere. Inside your phone's processor, inside your laptop, inside satellites orbiting the Earth, even inside the most ordinary home appliances. They quietly handle the work we never see, making devices faster, smaller, cheaper, and far more reliable. And without them, the digital world simply wouldn't exist in its current form. From banking systems to education platforms, from entertainment to global communication, almost every modern system depends on that tiny piece of silicon. As the saying goes, small sparks can start great fires. Kilby's spark didn't just grow, it spread across the entire planet. Of course, he remained humble about it. He often downplayed his role, emphasizing collaboration over individual credit. But history has a way of simplifying things, and in that simplified version, his name stands right at the center of one of the most important technological shifts in human history. So when you pick up your phone today, or open your laptop, or stream something online, you're not just using modern tech. You're interacting with an idea that started as a small experiment in a lab and ended up reshaping how humanity thinks, communicates, and lives. When people talk about Jack Kilby, they usually jump straight to the science, the chips, the labs, the Nobel Prize. But behind all of that, there was something much quieter, and arguably just as important, his family life. Kilby was married to his wife, Joan, for many years. And while his inventions changed the world, his home life was what kept him grounded. Because here's something we often forget: breakthrough ideas don't happen in a vacuum. They need space, stability, and sometimes, just someone who believes in you when things don't make sense yet. Kilby and Joan got married in 1949. Around the same time he was stepping into his early career at Texas Instruments, she was working as a school teacher in Fort Worth. Two very different worlds, but they worked. Kilby's job was intense. Long hours, constant problem solving, late nights where ideas either clicked or completely fell apart. But at home, things were different. Joan gave him something the lab couldn't: calm. Kilby once acknowledged that she understood the pressure he was under, and helped create a kind of quiet space at home where he could actually think. And that matters more than people realize. As the saying goes, behind every strong person, there is a steady support system. Over time, they built a family and raised children together. And even though Kilby's work often demanded his attention far into the night, he still made an effort to stay present at home. Not perfectly, not always easily, but consistently. Friends and colleagues often noticed something interesting about him: he didn't completely disappear into his work. He tried, whenever possible, to come back to family life, even if it meant simplifying plans or sacrificing rest. Weekends weren't always extravagant, but they were intentional. Time with his children, time with Joan, simple moments that mattered more than they looked on paper. And then there were the lighter moments. There's a small anecdote where Kilby and Joan jokingly talked about his invention and whether it could ever be sold like a product in a TV commercial. Kilby apparently laughed and said something like, "Maybe we just need to make it smaller first, and then figure out the marketing later." It sounds playful, almost casual, but it reveals something important. Even while working on technology that would reshape the world, he didn't treat himself like someone untouchable or overly serious. He had humor. He had distance from his own success. And that balance kept him human. There was another side of him too. After long, exhausting lab sessions, he would come home completely drained, and instead of isolating himself, he would step straight into family life, playing with his kids, being present, even when tired. And Joan played a key role in that rhythm. She would often lighten the mood with jokes, helping him transition out of the pressure of work and back into normal life. Because sometimes, the best reset button isn't rest, it's laughter. For Kilby, his family wasn't separate from his career. It was part of the same system that kept everything running. When he hit breakthroughs, Joan was often the first person he told. When experiments failed, she was there to listen. not to fix the problem but to help carry it. And over time, his children also grew up in that environment, surrounded by curiosity, engineering talk, and a father who quietly showed them what persistence looks like. As the saying goes, success is built at home before it's seen in the world. And Kilby's story fits that perfectly. Because while history remembers the integrated circuit, the patents, and the Nobel Prize, his daily life was shaped by something much simpler, a family that gave him the space to keep going. So when we talk about innovation, it's easy to picture labs, equations, and breakthrough moments. But sometimes, the real foundation is a quiet home, where someone makes sure the world outside doesn't take away your ability to think clearly inside. Jack Kilby's integrated circuit wasn't just a career milestone. It was a turning point for the entire technological world. Because once that idea took off, it didn't just improve electronics, it completely redefined them. Before this shift, machines were big, expensive, and limited. After it, everything started shrinking, getting cheaper, getting faster, getting smarter. And that change didn't stay in one industry. It spread everywhere. Computing was the first to feel it. Computers went from massive machines filling entire rooms to something you could eventually place on a desk, and later, even in your pocket. The real breakthrough wasn't just power, it was accessibility. What used to belong only to labs and governments slowly made its way into businesses, schools, and eventually everyday life. And today, when you look at a smartphone, you're basically holding that entire transformation in your hand. As the saying goes, good things come in small packages. In this case, that small package changed the world. But computing was only the beginning. Communication systems were next. With integrated circuits becoming more advanced, data could move faster, farther, and more reliably than ever before. Satellite systems improved. Mobile communication expanded. And eventually, the internet connected the planet in ways no one could have imagined in Kilby's early days. Now think about this, every message you send, every video call, every search online, it all depends on that same core idea of miniaturized, efficient electronics. Without it, the digital world simply doesn't function. Then came healthcare. This is where things get even more interesting. Medical imaging systems became more precise. Devices like pacemakers became smaller and safer. Diagnostics became faster and more reliable. In other words, medicine didn't just become more advanced, it became more accessible. And once again, the reason was the same, shrinking technology down to a level where it could fit into everyday life. As the saying goes, necessity is the mother of invention. But sometimes, invention also becomes the mother of entirely new necessities. Kilby's work also quietly shaped the mindset of future engineers. He showed that big breakthroughs don't always come from massive complexity. Sometimes they come from asking a simple question that nobody had dared to simplify before. And that influence didn't stop with his generation. Today, we're still living inside the wave he helped start. Artificial intelligence, for example, depends heavily on powerful and efficient computing hardware. Training AI models requires enormous processing capacity, and that's only possible because integrated circuits keep getting smaller and more capable. From voice assistants to recommendation systems to autonomous vehicles, AI is built on layers of silicon that trace their roots back to Kilby's idea. And then there's quantum computing. It's still emerging, still experimental, but even here, the physical systems we use to control and measure quantum behavior rely on ultra-precise electronic circuits. Once again, the foundation leads back to integrated electronics. So in a way, Kilby's invention isn't finished history. It's still actively evolving. Looking forward, we're talking about 5G networks, smart cities, and systems where billions of devices communicate with each other in real time. And all of that still depends on one core principle: powerful computing in incredibly small spaces. As the saying goes, the future is built on the past. And Kilby's past is still very much present. Of course, we may never fully know what was going through his mind when he first put that idea together in the lab. Maybe he saw something big. Maybe he just saw a problem that needed solving. But either way, the outcome is clear. Without that invention, the modern world wouldn't just look different, it might not exist in its current form at all. So the next time you pick up your phone, open your laptop, or stream something online, there's a simple thought worth remembering. You're not just using technology, you're holding the result of one quiet idea that reshaped the entire world.
The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.